Welcome to lesson 113, linear inequalities in two variables. So now we're going to be looking at inequalities. So maybe I need to do a refresher on inequalities. Here's our objective, our vocabulary, and our rules and notes. And so when we're talking about a linear inequality, unlike a regular inequality, we have two variables. And so basically just like a linear equation, we're dealing with a line. But now the solution set will be everything below or above the line. So now, what do we need to know? 2x plus y is less than or equal to 7. If we were to write that in slope-intercept form, you will see that the intercept is positive 7. And when we draw the line, the slope is down 2. So you go down 2 and over 1, down 1, 2, and over 1, just like in lines. That's how the line is drawn. The underline tells us every point on this line is a solution, and every point below the line, that's why it's shaded in, is a solution. Now, when we're dealing with greater than only, this one is greater than only, it's not underlined. Points on this line do not work. Like this point is on this line. So 3 is not a solution to this equation. And if I actually went through and did the math, you would see that. So what you need to know is when it's greater than or equal to, is up, is dotted line, is shaded. So this is how the solution works. The line is dotted or shaded, and the shading or the solutions are up or down, depending on less than or equal to. Or I shouldn't say shaded, I should say a better word. Let me say, is it a dotted line or a solid line? And this is a little handy keepsake to help you remember how to do the shading. If y is greater than mx plus b, you're going to have a dotted line, but every solution above the line will work. If y is greater than or equal to mx plus b, you'll have a solid line, and every point above the line will work. If y is less than mx plus b, whatever the line is, it will be a dotted line, and every solution below that line will work. And y is less than or equal to mx plus b, there will be a solid line, and every point below the line is a solution. That's what I mean by will work, is a solution to the inequality. Okay, so let's go through some examples. Mx plus b, our m here is 1. And so let's graph this by using the graphing method. We know our slope is 1. We start at 2. When x is 0, y is 2. And then we go over 1 and up 1, over 1 and up 1, over 1 and up 1, and down 1. And so what does this tell us? That because this is not underlined, it's a dotted line. So that means any point on this line is not a solution, and I'll prove it to you in a second. Because it's greater than, every point above the line works. So now you will be asked in your class to test some points. So I'm going to test a point below the line. Let's try 1, 0. I'm going to test a point on the line, 1, 3. And I'm going to test a point above the line, 1, 4. So watch how the colors work out. 1. All right. 1 and x. So 1 plus 2 is 0 greater than 1 plus 2. 0 is not greater than 3. It does not work. So we can see that the red the point in red does not work. Let's try the blue point, which is on the line. Y is 3 greater than 1 plus 2. 3 is not greater than 3. It is equal to 3. So this is why the blue point doesn't work. So now let's try the green point. 4 is greater than 1 plus 3. And we know that that's 2. 4 is greater than 3. So this works. And that's why the green point works. So this is how inequalities work. Linear inequalities. You have to have a line, and then you have to graph the whole thing and find a solution set. Okay, now less than knows we're shading down. Every point below will work, and this is going to be a dotted line. So now let's graph it, x plus 2. And I'm purposefully doing the same line to make it easier so you get the concept. Okay, so now that we did that, this means every point below the green line. No points on the line work, but every point below the line works. So how do I know that? We'll test out. We'll know that the red point is not a solution. The blue point is on the line, and the yellow point is below the line. So let's try it. So 3 is less than x is 0 plus 2. 3 is not less than 2. This is why the red one doesn't work. But let's try the blue one, because you're saying it's on the line, so it should work. 2 is less than 0 plus 2. 2 is not less than 2. It is equal to 2. And that's why it does not work. So now let's try the yellow point. 1 is less than 0 plus 2. 1 is less than 2. It works. And this is why all points below the line work. So when you're first starting out with graphing inequalities, your teacher, or you may get a test question or something like that will ask about a test point. Make sure you pick 3 points. 1 in a solution set, 1 on a line, and 1 above or below the line, outside of the solution set. So that's what I would like for you to do in practice. Okay, finally, graph this inequality. The first thing we want to do is make sure it's in slope-intercept form. This is in standard form, so we're going to subtract 4x from both sides. We have negative 2y is greater than or equal to negative 4x plus 6. Now we're going to divide the whole thing by negative 2. Now be careful with inequalities. Remember, when you divide by a negative, the sign flips. And I should probably put that in a different color, just so you catch that. Put that in a different color. The sign flips. You have a whole new equation. You get 2x minus 3. And so let's graph this one. 2x minus 3. When x is 0, y is negative 3. The slope tells us to go up 2 and over 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. When going to the right. When going to the left is opposite. Because is equal to, less than or equal to, we know the line is solid. And every point below the line works. I'm not going to do test points with this example because I've done it in the first 2 examples. I suggest that you pick test points. So if I was you, I would pick easy ones. I would pick 0, 0. I would pick a point on a line. This is 1, negative 1. And I will pick a point in the solution like 2, negative 2. So if I was you, I would pick my points and test them out. And you see the blue point is not in the solution set, the red point is on a line, and a black point is in the solution set. All right, so there we go. All right, let's try one more example. Okay, again, switching in the slope-intercept form, because that's the easiest form to graph. Dividing by -2 everywhere. So you get y. And again, this flips is greater than 2x plus 2. The sign flips because we multiplied or divided by a negative. Whenever you multiply or divide an inequality by a negative, the sign flips. So 2, we start at 2. We go up 2 and over 1, up 2 and over 1. And when we go left, we do the opposite. This is equal to, so, and then every point above it, because this is greater than, every point above the line works. And that's how you graph linear inequalities. So those were our 4 examples. We looked at a greater than, a less than or equal to, and a greater than or equal to. So we looked at the 4 kinds. So please work on the practice problems, and I will see you at the end of the video for a recap. Okay, is the point 0.04 a solution to the inequality? There are 2 ways to solve the problem. You can just put the point in. All right, so in a point, your x is always first, your y is always second. So doing it the algebraic way, we do 4 is less than or equal to 3, 0 plus 4. 4 is less than or equal to 4. So yes, it is. Or we can go ahead and graph the line. When x is 0, y is 4, 3. We go up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. So your line will look like this. And less than or equal to. So we want, even though this is a graphing, I did do the algebraic method first. And so let's plot the point 0.04. 0.04 is right there on that line. So yes, it does work. It works because this is a solid line, not a dotted line. If it was not equal to, you will see that 4 is not less than 4, algebraically and graphically. So here we go a little bit backwards. Okay, so let's look at problem 2 here. Is the point -4 a solution to the inequality? So the first thing we're going to do is do it algebraically. So -4n for x minus 4 times 0 is greater than -1. -4 is greater than -1. Is -4 greater than -1? No, it is not. No. All right, so on a number line, -1 is here, 0 is here, -4 is here. The further right you go, the bigger numbers get. The further left you go, the smaller numbers get. So keep that in the back of your mind about the number lines. And you can see right here, this is -1 and this is -4. -4 is not bigger than -1. Would you rather owe somebody $1 or $4? And I think we would all rather owe somebody $1 as opposed to $4. And there are no other scenarios in that situation, so we're not going to consider anything else. Okay, so now let's graph it. Okay, so the first thing we have to do is move the x over. -4y is greater than -x minus 1. Divide everything by -4. Y is less than, because we divided by a negative, so we flip the sign. So let me put that in a different color to make it dramatic for you all. Is less than. Negative divided by negative is a positive. 1 over 4x plus 1/4. Okay, so now let's graph this. When x is 0, y is 1/4. And then the beauty about the slope, that's the coefficient in front of the x, is that it will, it tells you how to move on a graph. So the numerator is your y, the denominator is your x. So for every 1 I go up, I go over 4. 1, 2, 3, 4. And left, doing the same thing. I go 1, 2, 3, 4, down 1. And this is less than, so it's a dotted line. And I'm doing all this the long way. Okay, dotted line means no solutions lie on the line. And we extend the line out. And every solution is below. Works. And where's -4, 0? -4, 0 is right there. And as you can see, -4 is not in the solution set. So it works graphically and it works algebraically, which means you have 2 points of consistency, which means the answer is correct. Let's look at the example. Is the point -3, -1 a solution to the inequality? All right, look here. Our things are mixed up. So we're going to do 5, 4, -1 minus a -3. See, I use 2 parentheses there to keep my sign straight. -4 plus 3 greater than or equal to 0. -1 is greater than or equal to 0. So that's true. All right. Oh, no, it's false. I'm sorry. -1 is not greater than or equal to 0. So now let's graph it. We got to move the x over. So 4y is greater than or equal to x. We divide by 4. We did not divide or multiply by a negative. So the sign stays the same, 1/4 x. So when x is 0, y is 0. And then we go over 4 and up 1. We go to the left 4 and down 1. And this is a solid line. And greater than, so that means every point above the line, all points, not just one number, but all points above the line work. And so what was our point? -3, -1. And let me put that in a different color. As we can see, -3, -1 is right there. It is not in the solution set because it is below the line. So again, when you first graph inequalities, please take some test points. You may be asked these questions in this way, you may not be, but please take a test point in the solution set, on the line, and outside of the solution set, and check your answers, make sure they're correct. All right, thank you for watching this video. We're going to start a series on inequalities. They'll take a couple of lessons, and inequalities are solved just like equations. The only difference is that inequalities, you deal with a larger solution set. So they're solved just like equations. So all of the equations videos applies to solving inequalities.